channel called Cross the Line on YouTube. This time I'm going to do a quick demonstration here just to talk about components, and the reason for it is because I want to discuss my machine learning algorithm in conceptual terms with respect to componenterization or compartmentalization, in other words, having nested components or components within components, but the phrasing and the verbiage that I'm going to be using throughout the course of my project description and analysis and all that is going to be sort of relative to a framework that I'm familiar with, just because those terms make the most sense to me, so it's easier for me to articulate what it is that I'm talking about when I go through that type of discussion. So it makes sense to just do a quick, just a rundown of a framework that uses components for web design, web development. In the mobile space, it works well for apps and everything too, and that's React. So React is an not open source. It's a free framework developed by the Facebook group, and it just helps developers create and compile JavaScript server-side objects and single-page web applications very succinctly. And they do that by repurposing JavaScript and creating another type of language, because it's got a built-in internal parser that takes strings of text and converts those into JavaScript functions, which it then converts through a transpiler and a compiler into more efficient and effective code that essentially gives itself other features like a life cycle and a state system. So state is going to be one of those things that we're going to look into a lot also in mathematical terms, but also in programmatic terms. So in math, those would be through state machines in like lambda functions and things like that. In computer science, it would be just relative theory basically for functional structures of input-output systems. You probably heard the common phrasing, garbage in, garbage out. But the way I'm going to do it here, I'm going to show a framework so you can see the types of things that you can extend JavaScript into. Like, it's so extensible as a language that you can basically kind of create other languages within it, because you can develop and create a parser. So that's why I call it a programming language, whereas it used to be considered, and a lot of people even still consider it a scripting language, is that a script basically just kind of automates a quick task or something with very deliberate commands, and it's a finite state structure. Whereas now the evolution of JavaScript has led it to server-side rendering and also creating rendering frameworks on top of itself, that it is fully fledged its own language now. But beyond its own language, it extends from because it can process itself locally on a client machine, in addition to processing on a server machine, in addition to basically creating its own language out of itself. So it's a very strong high-level programming language just because it can be operated as if it were a low-level programming language, essentially. And the way that's made possible, without having crazy lag and optimization problems, is first Google's development of the V8 engine, second Facebook's development of the background structure of the framework itself. So as long as you keep using the framework's built-in methods and algorithms, then it'll effectively run as efficiently as possible because they put their best minds behind it, as opposed to just kind of everyone reinventing the wheel, every man for himself kind of thing. But the way we're going to use it here is just to conceptually grasp how the idea of a component structure in the composition of complex algorithmic structures and entities and a state system that manages itself as well as other state systems and other functions of other state systems. And it sounds too hard to discuss without something visual, and that's why I wanted to use React in this video to show a visual representation of complex abstractions that we're going to be dealing with not just through code and not just through math, but also for the composition of dimensionality, basically, of algorithmic structures, of subsequent subnested models of other algorithmic structures, etc. So it's kind of like a visual representation of recursion in the sense of multidimensional programmatic functions. In other words, we're going to be doing lambda calculus, but we're not going to call it that because it sounds too confusing. We're going to do it visually. So I've just got VS Code open. I'm going to have another installation video that describes like how to set it up. It's really quick and easy. It's free. It's developed by Microsoft. Credit where it's due. Don't like Microsoft personally, but that's just because of a whole background of their antics and antitrust and all that. But tools are meant to be used, and I don't discriminate between good tools. So I do have to admit that it took me a while to get into it just because of my propensity to discriminate, but thankfully it didn't stick too long. So I'm going to start with, I'll make a directory first to house the code that we're going to be writing. So I think I've got, yeah, there we go. So I'm going to make a directory for our React project, and this is just temporary, so I'll call it like playground or something like that. And then I will change directory into it just so that that's my active directory, and you can see there's nothing in there yet because we have yet to start playing around. Now, first thing I want to do is, NVM, you got to check your version. Long form is -- version. NVM-V, I think, is the short version. Maybe? No? What's the short version? LTS, when installing, uninstall. Okay, so if you wanted to change versions, you can use NVM-use, and that's the Node Package Manager. This all assumes and implies that you've already got Node.js installed, and like I said, I've got another video for that. And it takes less than a couple minutes. It's really quick and easy. Yeah, anyway, I'm just going to skip through all that anyway, because I'm assuming that you have it installed. So if I say node version, it should tell me which version I'm using. That's the one that you can just, that's the one you can just use -v. Same thing. Okay, so npx, because the Create React app, you could install something globally through npm, but npx is sort of like a targeted install. It's a little bit over my head and hard to explain, but basically you only need to do this when you're starting a project. I don't use npx for absolutely anything else, so if you really wanted to, you could set this as an alias, just so that you don't have to memorize it, but I play around with React so often that you just kind of create React app. And then you put a space after that command is done, and that space is going to give you a spot to make a name for your project. So I'm just going to call it component project. Oh, right. No capital letters. You'd think I'd remember that by now. So no spaces or capital letters. And while this is all running, I might as well set up my VS Code because I've created the folder already. So documents, code, and React Playground component project. So I'm just going to open this here. Whoop. Yes, I trust. And then Control tilde to pull up the terminal. And that probably screwed up my whole install, so I got to do all this again. And we'll delete you. Okay, so cd ... to back up one, and then I'll create my node project again. Dooby-doo. So as you can see, it gives you the basic functionality built in, and if you want to test what these things actually do without just running them, Control B opens and closes this window here, so you can see all the folder, everything that's in the folder that I've got open is right over here. And within here you can actually define what these commands do. And you'll notice if I try and, well, first I'll show you that it works. So npm start. Oop. Component project, make sure you're in here, because otherwise it won't know where this command works, because as I said, npx is like a targeted install. So within this folder is where my npm commands will work for this project. So when I hit start, it's going to launch my default browser, and then it's going to set up a server-side rendered app, which is just the basic framework of the React starter project. And Control-Shift-I will open up my console again, and as you'll see, everything's working fine in here. And what you'll notice too is with this project, everything's going to update every time you save it because it's a live server, so it's a live update every time the files are changed. It re-renders the entire project, and the render lifecycle of React is sort of what makes it so wonderfully interactive, because it processes events without rendering the entire page. It renders like a focus point of just the component that you're trying to script. So if I comment a few things out here and then save it, you'll notice that my project actually has trouble running. And that's because anytime there's a reference, because it's running through strict mode, it's going to throw errors. So it's a bit more finicky, and unless you're really getting into web development and app development, it's not necessary that you learn this for the AI project itself. But showing you how the code can be transpiled, first of all, is informative in the sense that it shows you the power and flexibility of what you're learning, and the reason why I'm using JavaScript through these programs to do all my prototyping is basically for this reason. But the other reason I'm bringing this up is because conceptually how the componenterization works is going to be how I composite the machine learning models that I'm building through Blender. Because what I want to do is make substructures of Blender models and have hierarchies of models that control other models. So the inputs and outputs, not just for the training sets, but also for the operation and the deployment of these types of algorithms. I want them to be componenterized so that a substructure can render itself, or in other words, it can retrain itself or update its training models or its inductive priors or adjust its weights and biases optimally, because it doesn't need to re-render all of the weights and biases of the higher up organizational models that are then controlling it. So in doing this, hopefully we'll be eliminating a bunch of the dimensionality curse that sort of prohibitively makes the artificial generalizable intelligence AI systems that we're trying to create. It's what makes them intractable. So I'm basically kind of skimming away some of the intractability. That's the intention, for lack of a better word. But anyway, you'll notice that it updates live, and I'm in Linux, so I can alt space and then always on top, so I can play around in the background here and see that my window just stays up there, so I don't have to flip back and forth. So I really don't need any of this. It's just sort of there to demonstrate how things work, but I'll quickly run through what it's looking at. Here's a cascading style sheet for the color space and everything, and as you'll see, this is just a CSS animation that's triggered here with an @media infinite loop 20-second rotation on a linear gradient, not gradient, but smoothing method. What do you call that? The timing function, basically. So instead of something speeding up and then slowing down as it gets to the end, it's just linear. It's going to stay constant, the same rate of rotation on an infinite loop with a 20-second and you just set the name to whatever you want as defined down here. So @keyframes is a media... I don't even know what they call that either. But this is all just standard CSS, and React works entirely in standard CSS. And the benefit to doing that is, one, not only that there are a ton of resources out because CSS has been around for so long, but two, it's actually been optimized to already work with GPUs just natively through the browser. So again, you don't need to build a whole new infrastructure of APIs to communicate with the hardware in people's computers and then configure them with drivers to each and every different type of hardware or operating system that you're running through. Having everything run through a browser means that it'll work no matter where else you put it, whether it's on a cell phone or whether it's on a Mac or a Linux system or a Windows system. So CSS is actually kind of annoying in my opinion because you have to memorize basically all of these things. There's absolutely no help. You basically just have to look up every single string text combination that they want. But you'll notice with React, because we're using JavaScript, the JavaScript language uses and manipulates cascading style sheets, aka CSS, by taking out the dashes and then capitalizing this letter. So I'll show you that in just a minute. But just to give you a quick run through of what React is doing with all this stuff. So in our public folder here, the fav icon is this thing up here. Index is the landing page, and just because we use create React app, it's created all this stuff for us. So I'm going to take out all these comments, but you're welcome to use them, obviously. And here's the other comment I was looking for. So div root, this one's actually important. Title, I'm just going to change this to, what is it? Crossed, D-line. Machine learning intro to React for some reason. Whatever. That just changed this title up here. This is all basic HTML. What's important here is this, and it may seem innocuous and useless, and it's a completely empty page division tag, but the idea of root is what we're going to be injecting our entire app into. So if I control S and save, you'll see everything updates here. Package.json just gives us our dependencies, version controls. It says you can use this version or higher. These are the scripts, so npm start is what runs our script, and that's part of the React framework that runs this whole build here, which gives us our live reload and all that kind of stuff. I don't even use these because we're not doing deployment or anything, just as a testing library, so I'm not going to show you that either. So most of this you can ignore. But just so you know that the settings and everything are here, including like the name of the project and everything. So package.json is important, but I'm not going to cover it. So index.js is the JavaScript file. .js file extension is a reference to the JavaScript language. What it's doing is it's importing the framework here from the page. React DOM is how it renders the page, and you'll notice that down, where is it? Down here, where it's doing rendering. This root is just a variable that we're grabbing from React DOM, which is part of the framework we've imported here. And we're setting that as the root so that we can inject our entire app into that one page division, just using regular JavaScript. Get element by ID, and that's what this ID is here for our page division. And I don't need any of these comments because they're confusing. I don't need report web vitals, I don't think. Save, no errors, good. I'll take that out. Report web vitals isn't being used. As you can see, it goes a bit darker. This is what VS Code is nice for, as opposed to a regular text editor. It tells you, hey, this variable is not being used. So you can either comment it out or completely eliminate it. And it just kind of gives you visual cues to help you as you go along. So what's really important then is I'm taking this. This is JSX, JavaScript extension language. This is that parsed language that I was telling you about that was extended from the JavaScript language, and it's made to make React modules more easy to visually construct in your mind, like abstractly what you're doing, as opposed to just writing line after line of code and then trying to figure out, like looking at the screen of the matrix and trying to see like the reality behind the scenes. What it is it's sort of converting to HTML some of the complexity of saying like React DOM.create root or React.create element or something like that. So it just makes it simpler and easy to visualize where your components are going and how they're being structured. And as you can see, these are being nested within React, and then React has a sub method here, or sub property. I'm not sure what they'd call it technically, but strict mode just basically says it'll throw an error when anything is even slightly off. And you may think that's like annoying, but it's actually really handy, because if something doesn't throw an error, it could screw up your code later on, and then you could spend hours trying to figure out the logic where something went wrong, and there might not be a logical error. It's just that JavaScript in its own right is flexible enough that it'll try and mutate variables if something doesn't line up properly, and that can throw you for a loop down the road. It's really hard to debug. So better off to be strict than not, because you'll catch it right away before you get too far into it. So what app is doing is, all it's doing is taking this, where is it, app.js, and by convention you just use a capital letter. App is importing two things. It's getting the logo, which is the spinner here, and it's getting the CSS for this logo, which is just for what, color and size probably, and the animations and stuff that we looked through. Oh yeah, colors, centering, flex is just a CSS way of telling it how to render on the page. So yeah, really straightforward, not doing anything too fancy. But the app.js is what is important. I'm just going to get rid of the terminal because I don't need it right now. And I'm going to get rid of this page here because I don't need to look at it right now. It's just Control B. This is just standard HTML. It formats the text to look like a type of code, which is this here. So what was I saying? Yeah, so these are just standard HTML tags, but within the app, it's just a function, as you'll notice, and it's written as a JavaScript function. Like if I really wanted to, I could just console log here, like this is inside of the function. And when I save it, it'll pop it up right away, and you'll see that it populates and tells you exactly which part of which file is sending the console log, because remember this file is all running from the index.js, and this is running by grabbing the from the index here. I'll move these around so that makes sense. The index here is just rendering straight HTML with the root, and then we're injecting inside of the root this document.get element by ID. It grabs that page division that we ID'd as root, and that again is just standard built from the Create React app framework. And then we're importing our app.js, which this is implied. You just, like if I save it, it does the same thing. But because everything is JavaScript in React, they just let you omit it to reduce, I don't know, I guess people get eye fatigue from seeing too much code. I know I do. But and then all I'm doing is using JSX, which is, JSX, which is the JavaScript extension for React, the framework itself. So this only works, this type of structure of using like HTML tags or XML tags inside of a function call for JavaScript. It only works within a framework that's designed to take this as an argument. This is basically an entire string argument that's being interpreted by the framework. And that's what the framework is built for, basically, is to say, look, instead of having to type everything out in code and make it really hard to read, the framework itself says, if you use us, you can write things like this, and that'll make your development process a whole lot easier for yourself. So that is essentially the point. And that allows us to do a whole bunch of really powerful things. Like this is much more readable to anybody who builds HTML than writing a whole bunch of code that says like, the alternative to this might be something similar to like const header equals document dot create. Wow, I can't type. Create element. And then you put a string in here saying header as a type of header. And then I would have to say something like header.style. What are we changing here? Class name app header. App.css. Class name app header. So background color, for example. And then min height 100 view height. So this would be essentially the same as saying min height equals 100 view height, and then having to type another line, header.style.background color equals, and then there's that string that we put in here, and that was the color that we got from our CSS page, and we'd have to do that for every single line, like display flex, blah blah blah, right? So header.style.display equals flex, and you get the idea. So this is way harder to read than simply doing the HTML version, of this one right here, and then embedding nested tags inside of it, because then you can see just visually exactly what you're trying to do and represent, as opposed to this, you'd have to go through it sequentially and just kind of like build a model and render it line by line in your head, which is really hard to do. So why am I going through all this? We're talking about machine learning and I'm showing you web design stuff. Well, here's the reason to all of that. App logo, I don't need any of this. I'm gonna get rid of it. All I want to do is center it. Good. The reason why I'm showing you all of this is because there is an ability to, and I don't need the logo either. Actually, I really don't need the CSS either. Oh, I guess I will, because I just want to center it, so no big deal. So what I'm going to do in here, I'm going to add another component in our source folder here. I'm going to call these components. It's best to just group them together so that you keep them where you want them to go. And I'm just going to make like a header. But convention is to use a capital letter when you're building components. The JS file extension there. And then I'm going to do as we did before. So import React from React. And I use autocomplete because I have a terrible memory, but note that React has to be a string because that's from the library of React, but React is actually an object from within this library. So this will be a variable that gets used. Again, not too important for the purposes of this demonstration. What I wanted to show you is the nested componentarization. I don't know if that's even a real word, but to show the nested component structures and how sub-rendering is useful in any type of compositional project like what we're doing here. Or especially from compositional projects like we're doing here. So export default. And what's the name of my composer? Header. So if I'm going to be exporting an object, I'm going to want to create it. So const header equals, I'm going to use an arrow function just because that's the cleanest way to do this type of thing. And I'm going to assume I'm going to throw in some props in here later too. And again, this isn't too important right now. I'm just going to quickly show you what it means to render through a framework like React. So render, this is a method pulled in straight from the React library. But I don't need it for this because I'm doing a what do you even call it? There are two ways of making components that are exactly the same. There's the arrow function, or you can do the function. I'll show you the arrow function first. So for this, I just need a return statement. And in my return, I'm going to wrap this in a fragment because I don't want to overcomplicate things. Fragment's just an empty tag, but the way that the React framework needs is one solitary wrapping tag, basically. So everything that you return has to be wrapped in this one tag. No matter which tag it is, it can be a div tag or whatever, but a fragment is basically just a hollow tag. It's a placeholder, just so that we can play around with this stuff. And for later, I'm going to console.log our props, because I'm going to pass something into it later. But just for now, to show you what this does, is I'll make an h1 tag, and this is the text in my header. So now you notice it hasn't done anything, and that's because I need to import this header into whatever's being displayed in here, because remember the app is being displayed inside of our JS, which is right here. I could also just import it directly in here, and then I could place it above and below whatever else, but for demonstration purposes, I'm going to throw you in here, or show you in here, I mean. So import header from /components/header. And again, you don't need the JS just because of the framework. Technically, it's the exact same thing as saying .js, because that's the file that I've created up here. And now that I've put this in, the nice, neat thing about the framework is I can just type in header as if it were a tag and save this, and it's going to load in all the script that I put in from here. And what does this script do? Well, header is just a function. The function, all it does is return a string. My string is just my fragment, and inside, nested inside of that fragment, is some HTML. This isn't at all JavaScript. This is JavaScript, and everything in between these parentheses are just what's being returned by the function header. And then I'm exporting the function header. But what it's doing through the framework is processing nested tags for rendering and displaying through the browser. So when I save that and I check out app, you'll notice that this header gets displayed from within this div. And the way I can check to see that that div is actually doing that is I can write a specific style, just like common CSS style sheets, and I'll throw a border on it so that we can see, 4px dotted red. And you'll see this is the div that it's creating, and you'll see that this header tag is inside of this page division tag. Great, so what do the props do? Well, the props allow me to create any type of property I want, so I can pass information into that component. So I may not want to re-render this entire component every time this little piece of the component changes. And to do that, I'm going to quickly write, another property. Let's say equals testing. So all I'm saying is a property that's being passed in, the value of that property is going to be testing. And when I save that, you'll notice down here where I put inside of my header, remember the console log props? Props is a built-in keyword for React framework. And again, it helps us pass information back and forth through our component structures in a hierarchical manner. And I'll show you how this is really, really powerful in just a second. But I wanted to point out here that you can put anything in this. You can put a function into it. You can put a data set that you've imported into your project. So if you're using like financial data, you only have to import it once, and then you can pass it through all the subcomponents after that, because presumably that data wouldn't change. But if it did change, and every component has the change function to it, when one component changes it, every component that grabs it, anything that's updated through this props article here, those components are automatically re-rendered. And again, that's a feature through the framework of the specific and isolated rendering policies of the framework itself. So rather than rendering absolutely everything every time there's absolutely any change, it selectively goes through the entire DOM tree, the document object model, which is the rendering model for a web page or HTML. It selectively goes through all of the branches or otherwise nodes, all of the nodes on those trees, and then selectively updates just the ones that are critically using that piece of information that has changed since it was changed. This is phenomenally useful, and I'll show you how. So if I wanted to create a style specific just to this header, I might call it props.imported, or no, that might be confusing with the wording. So I'll say passed in style, let's say. What I'm going to do is I'm going to assume that I'm going to be passing in a variable for this, and that's why it's going to be bundled in props, because like I said, anything that's passed into that HTML tag, or the HTML looking tag, this header that I've created, which is just the name of this file, which is what I've imported to here as a variable, and here's the path that I've given it. I'm going to structure that inside of the properties, which comes just generically as part of the function of the framework. And then I'm going to pass that into this tag, which isn't actually HTML. It's technically wrapped inside. This is all JavaScript, right? But the framework allows me to embed this type of JSX, which is an extension of HTML. So I'm going to get my style sheet directly and dynamically from the properties that are called from when I pass it in here. So let me just close this quickly so you get more room. What did I call it? Passed in style. I keep forgetting. It's a terrible name for it, but just to give you an idea, if I use a generic name or something that's specific, it'll be confusing because often we'll just use a word like style because it's assumed developers know what we're doing and what we're talking about. But to see it your first time, you want to make sure that you realize that this can be any word that you choose. That's sort of why I'm picking it. This has to be specific to cascading style sheets, the keywords built into CSS. But this can be anything I want it to be. So as I'm passing this in then, I'm going to say this equals, I'm going to call it saved state, and I'll show you why in just a sec. So one of the other features of React is that you can use some pre-built hooks, and hooks are just built-in functions that help with the functionality of the framework. It's like an extension to the extension, basically. They're incredibly useful. You can't even basically do anything valuable in React without them unless you want to develop an entire project from scratch, which is excellent practice. But in practice, pragmatically speaking, it's not practical to write your own less efficient code than it would be to write more efficient code from that somebody else's, or not write, but use more efficient code that somebody else has already written, if it works better. So I'm going to import a hook called useState. And this is where we get into talking about our state machines. Where's my autocomplete? Help me. useState. There we go. Autocomplete's helping me out. So it's going to pull it in from the same React object as we got here from index.js from here. So this is importing React so that we can use React.strict mode. But now I'm using the same library, the same framework library, to pull in a hook called useState. And useState has to be wrapped in these curly braces for implementation detail. Not too important for what we're talking about here, but it's the same reason why I had to use two for this one. Is because the first one denotes that you're writing script, so it sort of escapes you from this JSX, the HTML lookalike that's embedded inside of the JavaScript. So it goes JavaScript function, JSX, back to JavaScript by using this. And then from within that, I need to embed it in a JavaScript object, which is JSON, JSON, JavaScript object notation. And again, implementation detail, but just so you know, there is rhyme and reason to all these patterns. So the past tense style I'm going to use is called saved state. So when I use useState as a hook, that means I'm going to create two objects here. One object is going to be a function, and the other is going to be a state. So it's going to be a value that I want to store persistently, and that maybe I want to update later. So the function is going to be to update that value that I want persistent, and the persistent value is going to be the one that I want to refer to when I want to use the data that's collected or gathered inside of it. So that means that the first argument, or the first variable I'm creating, has to match the one that I'm putting in here. And again, this could be whatever you want, but I'm choosing the word save state. And then I'm going to make the second one called set state, which is just standard convention. But useState is a function of itself, and you can leave it blank, or you can pass it in a value to initialize it. So as soon as it's created, it starts with a value, and then you can update it and change it later. So I'm going to start it with testing, and that's going to be an object with a value that just says my state machine is working. Oops. Well, I guess I don't need multi-lines. That'll fit on one line. So if you followed through any of the other videos where we got into code, this part should make sense. And then if you just sort of step back one step from that, this whole part should make sense, because what I'm saying, I'm just calling a function. I didn't write this function, it's built in, but I'm using somebody else's function called useState. And I already know what it does, so all I have to do is make sure that I use the right parameters for it, and then I can operate with it, right? This useState returns two values, and that's the reason why I'm destructuring these here. The return value from useState is it puts this whole object inside of this save state, and then the set state is actually a function that's returned from useState, and this function is only used to update the save state. You don't say save state equals to change it, because that would break the framework. The reason why is because you need a function call so that the framework in the background, without you having to deal with all the intricate details of like what to update, when to update it, what gets updated first, where's the priorities and all that, that whole hierarchical structure of rendering through the DOM tree only the components that need to be updated is done by using this type of hook, which is embedded inside of the framework. So basically, in other words, if I wanted to update it, I would call setState and say updated. This is a function call that updated my state. Now, obviously, this isn't going to be too handy right now because I'm talking about passing in a style sheet, and I haven't really done that, but maybe I'll say .style here. That'll make more sense. So, one object, it's going to start by creating this testing property of this object, and then I'm going to give it a property of updated. I'll call it updated state, so it's clearer. Now, I can put a comma here because it's just a regular JavaScript object, right? And from that, I'm going to create our style. And that'll be a little bit more useful for visual representation, as I promised earlier. So font size, I don't know, 75 pixels. We'll see if that works. Oops. We need an object here because CSS in the framework requires an object, and it requires that the values of the objects be strings. Unlike actual CSS, where you just write the word, and it's assumed it's a string. You can see by the color indent here, and then this is a keyword, that's why it's lit up blue. It's actually a property of the class of app. And I know this is a class because in CSS you put a dot before classes. Irrelevant to the point. What I'm getting at, though, is that this is just regular document object JavaScript object notation, except for the fact that I don't put dashes in here because those are incompatible. So use camel case for using CSS property value, property, what do you call that? This is the property value. That's the property. So CSS properties inside of an object notation. You use camel case to replace the dashes where dashes exist. So I'm going to add a couple more just so that it's a bit clearer what we're doing. So I'll add another border and we'll say 3 pixels dashed blue. Why not? That's just a short form. You could do like border, what is it? Border width, border style, border color. But if you just use the border, it's an updated version where it just, you put them in the right order and it'll do all 3 in the same line just because it's such a commonly used CSS property. So now that I've got this style as part of my state, all I need to do is pass this state into pass state. But what I can also do is I can give it a changed state. And if you can already follow what I might be doing here, is I'm going to pass in the function itself. So I don't want to call it. Using the open and close parentheses would actually call it. So it'd say, what does change state equal? It equals the value, the output, or the return value, or the product, in other words, of this function after it's been called. I don't want to do that here. I want the function itself to go into the component, because then with that, I can take the component, say, passed in style.style. Oops. What did I call it? Passed in style. Save state dot style. Passed in style dot style. That should work. Use state cannot be called at top level. Oh. I put it in the wrong spot. This needs to be inside of the component. Reason being, React hooks work inside of components. This is the JavaScript space inside of the script. So that's where the hierarchies and the organization of the code really come into play. Very important. So console log.props. Let me just refresh this. I'm getting errors. Too many recalls. I'm getting infinite loops here, and that's why it's not working. Too many re-renders. Is it going to tell me where? No. Oh, so every time this... Here, I got to use another hook here. Import use state, import use effect. Use effect is kind of a weirdly named one, but basically it's going to let me do this update, but only do it once. Whereas right now, every time this app function, this app component renders, it's creating a state every time it renders, and then it's updating and changing it. And then, like I said before, every time the state is updated and changed, it re-renders the whole app. And what does the whole app do? It creates a new state. So it's getting itself into an infinite loop. So what I need is another hook, and I won't go too much into detail into this one because it's a bit more confusing, but essentially all it's going to do is make sure that the code only runs once, as opposed to looping ad infinitum. So yeah, I think I should just be able to drop this in here. And then I need a function call for that, and then I need to drop this in behind it. So this empty array here is just, it's an opportunity to list a whole bunch of things for it to check and watch for and say update, process this script every time whatever you put in here updates, but I don't want it to update on anything except for the first time it's loaded. So leaving it empty is basically like saying, when the component loads for the first time, run this script, but that's it. Don't ever use this use effect again. And that should essentially stop my infinite loop, hopefully. And state cannot be called inside of callback, of course. So I'm going to create the state first in the app, then I'm going to update it, and that'll work. Beautiful. Complexity aside, all I wanted to show you is this. This is a terrible way of running your code. You should always break every component into individual apps or individual files so that you can segregate any problems that you have. But that wasn't the whole point of doing any of this. What I wanted to show you, though, was the console log of my header here. So now I can get rid of this, and hopefully this should work again. And it does not. Cannot read property style of passed in style. So I got passed in style. Oh, that's why. I already gave it the dot style. There you go. So you see, the difference here is I could have said, give it saved state. Everything inside of saved state. And then for the style, because what I'm giving it is a whole set of properties, but I really only wanted to give it just this style, not the updated statement here, but just this style object, I would have to put it on this side here instead. And you'll notice that the text changed size. So you'll see the flexibility with it too, and deciding whether to use it one way or another will ultimately come down to the logic of the code itself. So there's no real way to say like this is better than that. It really comes down to how the code is being written and implemented and how your dynamic systems are interacting with one another. Because you'll fall into this trap where you get these infinite loops where one thing updates the state and re-renders the component, and then the component re-renders and it updates a state which this other internal component uses, and then so it re-renders, and then one just feeds off of the other in a positive feedback loop, and then the whole thing crashes because it doesn't know what to do. Like it can't resolve itself, it has to keep finishing. And you actually find these problems in code for machine learning algorithms, but the issue is they're not visual. So when we're working with Python and we come into this type of problem, we get an error that says like too many loops, or the stack size is exceeded, or memory allocation has been exhausted, or any type of error like that. This visually is what we're talking about. It's the idea that one component is rendering and then causing the render of another component. But the nice thing about being able to process this in a framework in a browser is that you can see the changes visually, and you can pass things in with something more familiar like nested HTML, as opposed to nesting multidimensional matrices through NumPy arrays of a framework that you've never written machine code for. You know what I mean? So like the framework through Python is already abstract enough, but that's being processed and compiled in C through an interpreted language, which isn't compiled. So again, one of the benefits to JavaScript in a framework is that it's both compiled and interpreted. So it's basically one language that's essentially acting as if it were both languages that we'll be dealing in Anaconda with Anaconda with Python. And also in Blender, when I'm implementing those Python scripts and libraries inside of Blender, we're going to get these same types of issues, but we're not going to get at all descriptive explanations of why things are failing or why things aren't working, because I'm not going to get this visual representation. The entire thing's just going to crash. It's going to explode and say, like, my memory limit's been exhausted, and it's not going to give us any hint as to why. With any luck, the framework or the modules itself that we're importing, like PyTorch and TensorFlow, with any luck, they'll kick back some type of error when they check through our code before trying to run the compiled code from their libraries. I'm not yet entirely familiar with their systems yet, because most of the code I've run for machine learning through TensorFlow has just been taking an example project and then editing the example project to what my purposes are. So for this project, what I'm going to have to start doing is writing those from scratch, because, well, I mean, I'll still be using the example projects, but because I'm going to be compositing models of models, it's going to be a lot more complicated than just the documentations. You know, here's an example of how to get up and running. Beginner examples are great and helpful just to get a sense and a feel of how things work. But eventually you're going to have to start pushing the envelope, and you're going to get less and less help the further down you go with that type of analysis. So hopefully that makes a little bit more sense and a little bit useful, and hopefully you can see how this might... Oh, I should show you this actually first before we go. So within this app, I've imported the header, which is header.js. Within the return function of this, I also didn't show you another type of component, but yeah, anyway. Within this function here, I'll just change this so it's not as confusing. App equals arrow function. Literally the same thing, but it's less confusing because I'm writing it consistently now. So within this app component that I'm rendering out to my index file here, which is being imported here, I'm importing my header, which is from another JavaScript file, and I'm passing in the function to change the state, which comes from this use state here for our state machine. And that means that from within my header component, I can actually call this function based on the property of change state. And you'll notice that in my console output for the properties that I've embedded inside of that header tag that I created, remember I did a console log here, this function is going to allow me to change and update that state as well. So let's see, I'm going to change the style. So if I change the state, and that'll be the style property. So I'm going to take all of this, actually I need the whole thing, Control C. So in here, I can then say props.change state. What did I call it? Yeah, with a capital S. Wrap those in parentheses. And then because all of this is going to be part of an object, I wrap those in curly braces as well. So this object is a property of this whole object, or a value of a property of this whole object, and that's going to call the function that React knows to change the persistent state, which is the persistent variable of save state here, which includes another property, it includes this passed in, and it includes actually this function here too. So when I save this, I should be able to change the size of the text to, let's say, 45, and instead of 3 pixels, I'll say 1 pixel, and instead of blue, I'll say red, and instead of dashed, I will say solid. Or no, let's say, what are some fancy ones? Inset. Well, to do inset, you need more than 1 pixel, so we'll go back to 3 pixels. Look at all the errors I'm popping up. And the reason why I'm getting these recursive callbacks is because every time I change this state, it's going to re-render this whole app object, which re-renders this header object, which sends again the new value, because I'm changing it here. When I create the state, every time this app is rendered, I'm creating a new state, and then I'm updating the state right away, and then I'm passing it into the header object. So just from calling the change of state up here in the header, which is being passed in through this props, the properties from the function and call of the component, it's going to keep rendering out errors infinitely because it's just being stuck in a loop here. But the reason why I've chosen to do it this way is because most ways the computer will catch the crash right away, but because I've done it so abstractly, arbitrarily abstractly, just for the demonstration purposes, it doesn't quite notice that this is infinite, so it's going to keep counting up. But anyway, I hope that's kind of like a fun example of how compartmentalizing code inside of code and sort of making hierarchical structures of functional components is going to be relevant to having and establishing and deploying several layers of different types of neural network or not just neural networks, but like, convolutional neural network here, an SVM here, and LSTM over here, and, all the different types of neural networks, machine learning algorithms that are better purposed for different things, like computer vision, like an unsupervised model for clustering data, maybe another model for like edge detection and color correction, and another one for like noise elimination and fuzziness, and another one for like taking background noise out of an audio clip. You can bundle all of these individually trained models in different systems that work well for training those models on a minimal amount of data, which is essentially an optimization fix for a problem that is otherwise impossible to fix if you just tried to create one model that does everything on its own. And this is sort of my gripe with things like, not really a gripe, it's a criticism of the way that the industry is going right now, where they just think the bigger the model, the better. That's not how the brain works. The brain works by like breaking things into efficient little pattern recognizing structures, figuring out that one little structure, and then seeing how many different times and how many different ways I can repurpose that one little structure to do something else. So with our visual systems, we can take symbolic abstract representations visually and write down math. It's not that our visual, like our eyes and our edge detection and motion detection sensors and color detection sensors are physically, literally used for math, but we repurpose them so that we can do math in our head visually, as if we were writing it down, but in our head. And then we repurpose those same visual centers for things like learning, when we want to remap like memory and different connections that we've developed throughout the day through neuroplasticity and like how our brains evolved to build themselves structures and basically for learning and forgetting. Learning is basically a more pragmatic way of forgetting. Which I'll probably get into in a conceptual video. I don't want to get too far into it. But basically, your brain tries to learn everything, and then it has to cull and trim and cut off all the fat that's not necessary. And it's widely thought or believed that that's what's happening when we're sleeping, is that we're forgetting all the things that aren't useful, because we simply don't have the physical structure and capacity to learn absolutely everything forever ad infinitum. So, being really good at forgetting what's not important is what's really good at remembering things, as opposed to the other way around, where you're not trying to build as many structures as possible. What you're trying to do is retain the structures that are useful. And A brain that's really good at retaining useful structures and not cutting out anything useful is one that will remember more readily, and remembering things and recalling things are totally different, which again, I'll get to another concept video, probably in neurology or something like that, and by some type of biochemistry or something, but here it's finally crashed and reset itself. But the point is, the physical structures of the brain work in this compartmentalized fashion, where your eyes are useful for vision, yes, but they're also repurposed for things like knowing which way to look when your ear hears something in another direction. Like, that's a completely different center of your brain telling you which direction a perturbation in atmospheric, density fluctuations, which is what sound and auditory perception is. It's just patterns of oscillations and air pressures passing through your tympanic structure of your ears, right? But we have more than just our 5 senses. Like, we got senses of balance. Like, our sense of touch branches out into 7 other senses too. Like, you've got pressure sensitivity, heat sensitivity, texture sensitivity, and you've got the awareness of where your hand is, and you have the awareness that your hand is attached to you. And then you have the awareness that the tool in your hand is an extension of your hand. So those types of senses are just compositionally built one on top of the other, rather than reinventing the wheel for a whole new structure, figuring out how to swing a hammer from scratch. It says, well, I know how to swing my hand, I know how to grip my hand, I know how to see my hand, and I know how to see what my hand does to an object. And it reuses, like functional components, all of those separate parts of the physical reality that it's I'll just quit that. The physical reality that your brain's compositing together. And that's also the reason why when you see things like, if you're watching a basketball game from close up, you'll see a ball hit the ground the same time you hear it, and that's your brain composing a time structure. We actually have a sense of time. It's developed and composited inside of our brains. So when you back up, if you get away, I think it's something like 80 milliseconds or 100 milliseconds, maybe 150 milliseconds, something like that. If you back up 100 feet or 200 feet, when you get far enough that the light reaching your eyes has a gap of 100 milliseconds different, or whatever the number is, different from the time it takes the sound to reach you, all of a sudden you'll notice that the sound disconnects from the ball. But it's not gradual. Your brain can composite these two things together and combine them into one delayed perception of a ball visually and auditorily hitting the ground at the same time. But eventually you get far away enough from the basketball game that suddenly, that one step further back, you get this disconnect, it's an asynchrony of perceptual awareness from the same object from 1 foot closer. And that type of compositional awareness is what I'm trying to project inside of an artificial general intelligence network. But I need to get the subsystems to be trained independently first, which we have tons of. We have BERT and ResNet and ImageNet and, all these free and open source projects, but there's also the ones that aren't free and open source. Like, if I give my project to them, then they can incorporate it into their work too, right? So the point is composing these types of more tractable models and combining them together. In my hypothesis is that'll be the way to compositionally structure an artificial general intelligence network. And that's sort of our primary objective in this project with Cross the Line. But doing that through a 3D graphics engine like Blender is going to help me visually compose and structure these types of models. So in one of the next videos, I'm going to show you how it's called nodes for material rendering in Blender, but it's sort of confusing, and the reason why I hesitate is because Node.js is a completely separate thing from nodes in Blender. Blender being the 3D graphics software, a node compositor or a node editor is basically having just input-output systems for describing the way physics-based rendering is going to work on light bounces and ray traces when we render or rasterize graphics or three-dimensional environments inside of Blender, whereas Node inside of a computer programming structure is more talking about like graph network structures in relationships between functional components, or basically lambda calculus but in English, or half English, I guess, if JavaScript's its own language. But anyway, that's probably good for now. If that was completely unclear, obviously, give me some suggestions in the comments. I'll try to answer anybody questions as I got them. Sorry about the sparsity, or not sparsity, but the spasticity of the releases of my videos on this channel. YouTube's giving me grief about copyrights, so I'm kind of sticking it to them by throwing more stuff. I have music that I have licensed. I've got like 70 different tracks, so if they're going to call a copyright complaint on every single one, I'm going to dispute 3 times per video instead of just once, until they get the picture, because they've got the AI. They should recognize that if I use the same audio twice and I keep getting my dispute, I keep winning my disputes, then they should stop accepting people frivolously filing disputes against me. So anyway, enough of my ranting, enough of my billing. Hopefully that was helpful and insightful, and if not, maybe it'll become more clear as we go along in the project. But again, this is sort of just meant to be an introduction to the way I plan or project to be compositing AI algorithms together, as opposed to making one big model like GPT with 1 trillion parameters. I'm going to make a bunch of small models with 1,000 parameters and then stitch them together. And that's the premise.